So row equivalent or equivalent means the systems are the same. So that means if you do row operations, and that means one of these three things, right? You switch the two rows, you multiply one row by a non-zero constant, or you multiply a row by a number and add it to another row. So those three things keep the systems equivalent. Okay, how about this next one? What are the possibilities of solutions? So if it has a solution, that means it's consistent. So it's either unique solution or infinitely many solution. So are all the row operations reversible? Yes, you can undo all the row operations because you can unswitch the rows. You could multiply by the the multiplicative inverse of that number you multiplied through by, or you could undo this by using the additive inverse. Okay, if the system is consistent, is the solution unique? No. Consistent means either infinitely many solutions or unique. So just because it says consistent does not mean unique. Okay, so if it's consistent, is that the same thing as saying, does there exist a solution? Yes. Consistent means there is a solution, and just like we talked about, it's either unique or infinitely many. So consistent means a solution exists, right? Existence. Okay, so when trying to determine if a system is consistent, explain why it's not necessary to solve all the way, solve completely. So if I do row operations, and it can be done so that the augmented matrix does not have a row with 0, 0, 0, 0, and then B, so I should put a 0 here. So all zeros and then a number at the end where the B is not 0. If it does not have that, it is consistent. If it does have 0, 0, 0, 0, and then a B and the augmented matrix, then it is inconsistent. Two matrices are row equivalent. Does that mean they have to have the same number of rows? Yes, because row operations don't change the number of rows. And what's the difference between existence and uniqueness? So existent means consistent. So you've got unique or infinitely many, right? If it's unique, that's just one solution. Can two equivalent linear systems have different solution sets? No. If two systems are row equivalent or equivalent, that means they have the same solution set. So here we have 3 lines, and I don't need to go through and solve it all. I just need to find out, does it have one common point of intersection? So that means at least one. So it means I'm looking to see if it has a unique solution or if it's infinitely many. So I make the augmented matrix. Be careful writing them all down. And all I did was take row 2 and add it to row 3 so I could get a 0 here, right? And after I did that, I get this matrix, and look at that. I know this is an augmented matrix, right? So this gives me 0 equals 3, so it's inconsistent. So I don't need to go any further than that. Here I have the problem. I want to find out what the H has to be so that this is consistent. So I need to get a 0 here. So I multiply row 1 by -2 and add. And so this gives me, that looks kind of messy, 5 minus 2H, right? So I need to have, in order for this to be consistent, I need this to not be 0. Not be 0. And so that means H cannot be 5/2. So you can use any other number except 5/2. Same thing for this one. Do row operations first. Get a 0 here. So I multiplied row 1 by a -2 and add. Remember, you're always adding. And so that gives me this matrix right here. Okay, so part A. When does it have a unique solution? Has a unique solution if this is not equal to 0. So that means H does not equal 8. And when does it have infinitely many solutions? Or I'm sorry, when does it have no solution? No solution if this is 0. And so that would mean when H is 8.